Hey everybody, this is now the fourth time that I'm going to do this fourth page. Hopefully this time it'll take. All right, let's go for it. All right, so the first equation that I see in red is a special case, y is less than or equal to 3, which is a horizontal line at 3. So I'm going to go to my graph and I'm going to draw I don't know why I can't get rid of that for you. There we go. I'm going to draw a horizontal line at the y-axis that goes through 3. Because it said less than or equal to, I'm going to grab my red highlighter and I'm going to shade below. Anything smaller than this line is a solution to the first equation. The second equation, we'll do blue. Okay, so I need to move that 7 over here to the other side, put it underneath the other constant on the other side, which is weird that it's in the front, but that's, it is what it is. So bring down your y. What's kind of nice is those 7's cancel, so you're only left with the absolute value of x minus 1. This is an absolute value problem, therefore it will be a v. The vertex is opposite of the inside, positive 1, and the number in the back, 0. Again, that is opposite of the number inside, 1, and the number in the back, 0. The slope is the hiding number in the front. Since it's hiding, it would be a 1 over 1. Let's go ahead and plot that. So I'm going to go over 1, up 0. That is my point, my vertex. And now I'm going to go up 1, over 1 on both sides to make a V shape for my slope. So this was my vertex. This is my slope. It was greater than or equal to, so notice I'm using a solid line because it was equal to. And because it was greater than, when I shade, I'm going to shade above my V. So I can see this double lap overshaded area here. I'll highlight in dark purple. Anything inside of this triangular area is a solution to both equations. If we wanted to check that, one of the points inside of this area, for example, 1, 1 would be inside of that area, would fit both my red and my blue equation. So y is less than or equal to 3. I would plug in my y value and my point 1 is less than or equal to 3, check. And if I wanted to check my maybe a little more complicated inequality, I'm just going to put 1 in for y, 1 in for x. So I do 1 plus 7 is greater than or equal to 7 plus 1 minus 1 in absolute value. 1 plus 7 is 8. Let's see if we can do this. Well, 1 minus 1 is going to be 0. 7 plus the absolute value of 0 is 7. So 8 is greater than or equal to 7, which is good. I'm going to check my screen recording, make sure we're still good to go. We are. Good. Let's make it through the last example before it shuts down again. All right, the first equation, negative 1/3 x minus y is greater than negative 1. I'm going to move this entire term over, and the only way to do that is by adding the entire term. The x is on the wrong side. Drag down the negative y, the greater than side, put the positive 1/3 in the front, x, and then the minus 1 in the back. Don't forget we have to divide by negative 1. So it's going to turn into a positive y. My sign is going to flip because I'm dividing by a negative. I'm going to have a negative 1/3 x, and that negative over negative is going to make a positive 1 in the back. Let's graph this. I'm going to go to positive 1, go down 1 over 3, down 1 over 3. This is not, I didn't go over 3 that time. This is not a V shape because it's not absolute value. I do not have the broken line tool on mine, so what I'm going to do is I'm going to do my best to kind of freehand this. Okay, so a broken line, and I'm going to be as detailed as I can because I know the answer is kind of odd. It's a really tiny area once we get done with this problem. Okay, and I think I need to shade. Let's see what the sign said. Broken because it's not equal to, it says less than. So anything under this red line, anything under the red line is an answer. Now let's do blue. I hear kids coming down the steps, so I won't go too fast, but fast enough that it won't affect us. Y is greater than 2, absolute value x minus 1. This is going to be a V shape, so I need a vertex of opposite of the inside, 1, the number in the back, 0, the slope is 2 over 1. Let's plot that point. So I'm going to go over 1, up 0, very similar to the last problem so far. My slope was up 2 over 1. My slope was up 2 over 1. I'm going to connect those with a broken line. So I'm going to zoom in. It's broken because it's just greater than. It's not less. It's not equal to. And it said greater than, so we're going to shade above this blue area very slowly and very carefully. You can see the double intersection here. I'll highlight it in dark purple. That dark purple area is our answer, and only any like decimal answers that fit inside of there. Something to note is that the broken lines are not solutions. There we go, are not solutions. Because if it's on a broken line, it means that it would like not be equal to. So anything on our lines themselves would not count. Anything in the double shaded region are the only things that counts. All right, we're still recording, so let me make sure that I say we will have a quiz on 3-1 and 3-3 the day following the 3-3 practice problem. So if you're doing your notes at home, before 3-3, we'll have a quiz, not the next day, the day after that. But if you're doing your notes in class, we have a quiz tomorrow.